Hello, I'm Adam, and today we will use a lot of toys to check something interesting. As you remember previous video, this is MiniPC, and it works with 32 gigabytes of RAM, and by the way, the Be Quiet heatsink in the Pro version fits just perfectly, and I can close the lid without problems. Yeah. But this video will be about powering this thing, because this thing consumes about 6 watts in idle, in my case, with only one Ethernet. Sometimes it bumps to 7 watts or something, and maximally up to, let's say, I saw 23 watts. So what does it mean? It means that this thing can be powered by this. Oh my gosh, yeah, you'll see a little bit of this thing. This is Ubiquiti PoE Switch, and this thing has a PoE plus output, which is maximum 30 watts per one port. That means it could work. And in this video I'm about to test PoE splitters, because this thing doesn't support the PoE. It supports only 2.5 gig WAN and LAN. So in this video we will test something like this. This is very basic, cheapest PoE switch. We will check the Digitus one PoE switch, which has rating for 24 watts. So that should be enough. Yeah. Next, there is few words about this. This is a Polish brand. This is just the very cheapest Chinese thing, but just in Polish brand. Yeah, so you can find it on AliExpress for about few dollars. Digitus is, well, it's brand, and you maybe heard about that, from Germany. And next there is something, I think this thing is from Poland, and yeah, this is the company, and this thing looks, let me unbox it. And this thing looks like this. Yeah, PoE plus splitter. Okay, and those things has some switches to switch to 24 volts, 12 or 5, 9, etc. And additionally I will test the TP-Link one, which is very similar to this one, to the Digitus. And what we will test? The first thing, let's talk about PoE. What is it and how does it work? So generally, PoE, as name says, it's power over Ethernet, and so that means we'll get a random Ethernet cable, and in this case there is 8 wires in about half millimeter square size, and that's sufficient to power some things. Yeah, and PoE standard is pretty, well, I didn't expect it that this standard went to this side, because this direction, because in the PoE standard we are using AC voltage to power something. AC is better for longer distances, so yeah, that's great. And in PoE we will get about 50 volts AC voltage, yeah, and that's, let's say, good for distances, but we need something to rectify the voltage, some power converters, etc. Yeah, and that's takes it takes a space, and yeah, generally it's more complicated to use it. And that's why it's not standard in every PC or mini PC, etc. Yeah, and here comes those things where you can insert the PoE plug, and you got splitted the Ethernet out and the power supply. Yeah. Okay, and those things are gigabits, are gigabit rated, but this thing got only 100 megabits. I just checked that after it arrived that there are only 2 pairs of wires, so for sure it's 100 megabit. But anyway, this thing got rating 1 amp at 12 volts. There we've got 25 watts, and there we've got 24 watts. The TP-Link is very similar to the Digitus, but we will see if inside there are two similar, or I don't know, maybe someone will be better. Okay, so what I'm going to test in this video, because there's a lot of things and even more. The first thing, I'm about to make sure that if I will decide to power my MiniPC from PoE, I would like to choose the decent power supply, because you would need a decent power supply if you want to run something 24/7. Decent, I mean, like it will don't have a very big noise, it will have nice stabilized voltage even under the load, and there is another factor that you will have a good power efficiency. So it's in good power supplies at this moment it's around 85%. How does it calculate? Generally, if you've got a thing that consumes 9 watts of energy, the total output from the socket will be about 10 watts. Yeah, and yeah, whatever. Okay, so but why I decided to go for PoE? Because the Ubiquiti Switch, oh my gosh, it's getting hot. That's very big downside of this thing. The PoE Switch has 120 watts available for PoE, and something is running there to provide the PoE. And if I connect only access point to this thing, I will utilize about 6 watts of this PoE budget. So yeah, I'm about to maybe connect a Philips Hue bridge to this thing through the PoE, and I hope for MiniPC and maybe other things that require 5, 9 or 12 volts or even 24. And I hope everything will be fine. Yeah, there is an oscilloscope, and I'm about to connect the outputs of the DC out, and we'll check how smooth is the voltage output from the PoE splitter. And after that I'm about to use load. In this case I've got 15 ohm resistor to the standard DC jack, and at 12 volts it's about 9.6 watts, so this is a little bit higher than the MiniPC we consume in the idle, so we'll consume most of the time. So I will compare it with this thing, and yes, so let's get started. What will be interesting for me is the VPP, and now I will show you, just to take a note. Yeah, and as we can see, VPP is 240 millivolts, and let's say it's our referential state. And now I will put a load and we will see how it will be under the load. Okay, I will try to show you, but it's the same. And oh, you are able to see that we've got 9.4 watts, and there is about 0.789 amps at 12 volts, of course. Okay, and because the heatsink is getting hot, we've got our reference values. And now we are going to check what values we will get on the PoE adapters. Yeah, generally what I saw now, without connected everything, we've got VPP 240, so that doesn't mean my power supply is let's say bad or something, but to be honest, I'm not sure how to operate this TV, so yeah, maybe it's the noise around, because there are a lot of things, and those of course are not isolated to noise, and maybe, yeah, it's the fault of the probe, not sure, because this is an antenna, whatever, yeah. So let's test this thing out. I think this is the input, this is the output with the voltage, and okay, so oh my gosh, I will fight with cables a lot. Okay, we got 12.4 volts. I would be afraid if I will connect it to my MiniPC, to be honest, because it's well, it's too big. Maybe it's at the very border of the 12 volts spec for the PC. We can see that the switch shows that the PoE port consumes 0.4 volts doing nothing, yeah, being idle. So now let's connect the load. I can see 12.5 watts is reporting the PoE switch. Let's check the voltage on the resistor. No, okay, we've got 12.3. I would need alligator clips, whatever. We've got 12.3 volts. Did you saw that? Yeah, you saw that. So under the load we've got 12.3 volts. And the various values on idle are like this. You can see. So we've got higher VPP. And now I've got good contact. Oh my gosh. As you saw, the multimeter was flickering. Yeah, so VPP went to almost 500. Okay, next. The Digitus one. This is very similar to TP-Link. That's how it looks like. As we can see, the build is very different. We don't see the chip as I named the PoE transformer, the Ethernet transformer. We consider a lot of coils, 2 diodes for making the voltage rectified, and yeah, and I googled this chip. This is the power converter, which accepts up to 60 volts. So generally there is a rule that we rectify the voltage, the AC voltage from PoE, and its output to the power converter, and it goes to output. And yeah, generally that's it. There is a selector because this power transformer, this power converter got switching output. 12 volts, green light. Let's read the 0.6 watts is Ubiquiti reporting. Let's measure the voltage, and okay, I will take this out so I will get a little bit more space. So there is an output, and let's check this out. 12.3 volts. This thing got even worse values. As you can see, VPP is 800 millivolts. Wow, this thing is garbage. Let's check what we'll get on the load, and that's interesting. Okay, now it got applied. We've got there the switch is reporting 11.6 watts. Let's check the voltage under the load. And under the load 800 millivolts, 800 millivolts of VPP, that's a lot. And let's connect the PoE in. And it's 12 volts, 12 volts. And in the idle, wow, promising. This thing in idle consumes 0.3 watts. Promising. Let's check the voltage output. $12.4. But it's stable. Look at that, it's stable. This thing costs a lot, about $40. Okay, let's check the oscilloscope. As we can see, 1 volt VPP. Under the load, the PoE switch is showing as 12.2 watts. We've got VPP around 1 volt. 12.2. Okay. Wow. It's massive. We've got the grounding, selecting volts. This is transformer in heatsink. Wow. There is a network transformer, and it's supported 2.5 gig Ethernet. A lot of things there. Okay, so I've got very new TP-Link PoE splitter. Unfortunately, this thing is only 10 watts, but it has selectable as a Digitus voltage down to 5 volts. I think this is version 5, and I think the Digitus was a previous version. So let's check if is it working. Yeah, that's strange. So it needs a load to work, and at this moment it's connected. The Ubiquiti switch reports 11.7 watts, so that's, I think, pretty nice. Let's check the voltage under load. $11.85. That's quite a low, but we are almost at 100% of the power budget. Yeah. Now let's connect the oscilloscope, and that's what we've got. Well, that's nice, I must say. The voltage on the load 4.9 volts. Okay. The switch is reporting 2.9 watts, and regarding the oscilloscope, we've got those values, so that's pretty nice. Let's check the resistance of the resistor when it's hot. 1531. When it was cold, I had 15.09. So that's significant, but don't get crazy. Now let's compare the standard power adapters. There I've got the power supply, which I've got with the oh my gosh, with the MiniPC, and as we can see, the parameters are there. 12 volts 3 amps, the most Chinese thing. Chinese. Next I have got the old but genuine Delta power supply, and it's 12 volts and 3.3 amp, and we will see what will happen if we connect it to the oscilloscope and to the load. Yeah, okay. And at the beginning there goes the power supply which I received from the with the MiniPC. In the idle my power socket adapter that with the display that shows the current is showing generally 0, so it's under the scale, but it should draw about, I don't know, 0.5 watts or something. Let's check the output voltage on the idle. 12.2 volts, that's okay. Let's connect the oscilloscope. As we can see, the values are there. So 600. Let's check how it performs under the load. 320. But yeah, that's weird. I mean, yeah, great. And now let's check how the Delta power supply will perform. This one. Let's check the DC voltage from Delta. Wow, 12 volts and that's it. Can you see that? Yeah, you can see. Just take a look. I've got about same result as my laboratory power supply. Let's check how it performs under the load. That's strange. Just look. So let's say about, I don't know, 5 milliwatts, 500 milliwatts. Okay, and just from curiosity, let's check the Delta power supply, but this thing is from my Acer Verton. It's 19 volts for amps, and yeah, let's check this thing out. I assume this thing is too pretty old one, but we will see. It's 19 pretty nice volts. Okay, the values are there. VPP 600 millivolts. As you can see, 800 millivolts. Let's move to the summary. I will split summary into two parts. The first part is about PoE adapters, and the second part will be about power supplies which I tested. So about PoE splitters, as we can see, they've got generally 80% of efficiency. That's, let's say, just acceptable. Gigabit PoE splitters were able to negotiate 2.5 gig speed, so that's great. And that's it generally where pluses are. Because PoE splitters are not a good choice to power your MiniPC. Why? Because as we can see, at the without the load, we've got high voltage. Even with the load, we've got 12.2 volt, 12.3 volt. In the TP-Link it has 11.85 because we were almost at the limit of its wattage rating, so yeah, generally at lower currents it should be fine to be about 12 volts. But what I mean, to devices like MiniPC or anything which takes the input voltage 12 volt in this case, it's the main 12 volt rail in the PC, so There is a PC standard which says something about, I don't know, maybe 5% deviation. After checking those splitters under the oscilloscope, yeah, I think those values are at the limit. Under the load, voltage maximum is about 12.6 volt, 12.7 volt. So those are very tiny, very quick spikes that can seriously damage the MiniPC. And yeah, that's very big issue. Only the 1 Digitus could maybe be fine with that, spikes up to 12 and 2 volt. But from the other side, it has spikes down to 11.4 volts. So yeah, that's 800 millivolts voltage peak to peak. And oh my gosh. So summarizing, unfortunately, PoE splitters are not designed to power MiniPC or other, let's say, expensive, important things. Those are designed to power things which anyway has the power converter built in. So, for example, if we've got a camera which doesn't support PoE, we can use PoE splitter and put there 12 volts, and anyway in the camera there are power converters which lower the 12 input to, for example, 3.3 volts. Yeah, and for this application it doesn't matter if we get 12.2 or 11.4 because anyway the power converter will handle that. Yeah, so that's the, let's say, summary of these tests. So unfortunately, don't use PoE splitters to power your MiniPC or other expensive things, because to be honest, those values are pretty poor for, let's say, power supply. Because not just because the efficiency is just, let's say, acceptable. I mean, good power supply has above 85%. Very good has about 90% of efficiency. What's more, I thought about scenario where I can power my Philips Hue bridge using the TP-Link, and unfortunately I was thinking about using PoE because my switch has a lot of free budget on the PoE, and I thought maybe it would be easier to just connect thing to something what is working already. But unfortunately, as you can see, after applying same load, 50 ohm, which calculated should be about 1.6 watt, the PoE switch showed almost 3 watts. So there is no way to power something like Philips Hue bridge efficiently. Yeah, so I think that's all regarding PoE splitters. Now let's move to the power supplies. And now there is very funny part, because I said even in previous video that the Chinese power supply included with the MiniPC is very Chinese, and I'm afraid to use it, but oh my gosh, as you may read those values, what happened there? As we can see, under the load, we've got a nice 12 volts using the included power supply. The old one, PSU, has almost 12 volts, that should be fine. And the Acer got, yeah, that's okay, about 19 volts, because it's the 19 volt one. But power efficiency, let's say, is a little bit better. But as we see on the oscilloscope values, on the load Vmax is 12.3. The minimum was 12 volts, so let's say it was pretty stable, yeah? And VRMS, and as we can see, the VPP is only 320 millivolts. So I couldn't believe that this thing is, well, okay. But why it's okay? It's okay because it's new. And I'm not sure how it will perform after about a year or something. So yeah, and why the next PSU or the even further were so bad? As you can see, 12 volt. As you can see, 12 and half volt on the Vmax and 11.4 Vmin. Why? Because this is pretty old PSU, and the capacitor is just worn off, and yeah, I've got about 1 volt voltage peak to peak. So generally I wouldn't use it for the MiniPC scenario. What's more, I bought it for MiniPC scenario, but after measuring it, if I will get a 12 and half volt spike, it might damage something, yeah, or the lower spike can just make system unstable. But moving further, I've got the Acer Verton PSU. Fortunately, this case is 19 volts, so there are power converters to 12 volts, to 5 volts, to 3.3 volts, to 1 volt for the CPU, etc. Yeah. So in this case, we don't risk damaging something or burning something. So generally we can accept some deviations, but look, it has 19 volts, yeah, and under the load the maximum on the oscilloscope is 18.2. Yeah, we've got 19.2 volt at the Vmax. Yeah, I'm not sure about this score, but check the voltage minimum. It has 17.4. So yeah, we've got a lot under the 19 volt, but anyway, it's fine for this case because, as I said, we've got power converters which are working, for example, from up to 15 volts. Yeah. So the moral is that buy a new power supply. Don't use old power supplies what you have found somewhere lying. And the example of the really good and modern power supply is Minwell. And Minwell announced the NGE 30 series, and we've got already the parameters like 120 millivolts volts peak to peak, which is wow, it's great. Then we can see there is efficiency 88.5%, but after digging into the report, we can see chart comparing the efficiency versus the load, and as you can see at 230 volts, at about 30% of load, we've got 90% of efficiency. So that's wow, yeah, that's amazing. But unfortunately, at this moment, this power supply series is not available yet in the stores. But it shows us where modern new power supplies are going. Yeah. So I think that's it for now. Yeah, to be honest, I'm not satisfied because I thought that I can use PoE Switch to reduce energy usage and to reduce sockets. Yeah, but I'm not reducing the energy, and yeah, in long-term use, it's noticeable difference. Yeah, so unfortunately, I will go for the nice quality power supply for the MiniPC, and we'll stay with the Philips Hue Bridge stock power supply. Yeah, so this is the moment where I spent, let's say, about 5 hours on making this video, editing, etc., and the results are like yeah, now I know. But I spent a lot of money for those PoE splitters, and in few words, yeah, they are not designed for purpose what I imagined. It is how it is. Thanks for watching. Please leave a comment and hit the subscribe button. Bye.